Okay, so today's class we are looking at geometry. We're going to start by looking at plane geometry and then we'll get into angles and measurement. So it all starts with a point. A point or just like a dot like that, that would be a point. So we have to start by learning the language of geometry and how geometric figures are developed. So it all starts with a point, which we define as an idea or a starting point or starting position in mathematics. So it's a capital letter that's always used to name a point. So here, if we had point A, we would call it point A. We could have point B, and it would be called point B. All right, so after the point, we would have a line. So it's composed of an infinite number of points. Okay, so as I was saying, a line is composed of an infinite number of points. So there's points all along this line, but any 2 points can be selected to give it a name. So in this case, point A and point B have been selected, and now we can give this line a name, and it's called AB. So what we do is we put like that, and it's called AB. So that is how we would represent line AB. Next, we can have a line segment. A line segment has definite endpoints. So 2 endpoints. So if you compare that to the line here, it was continuing on both ends infinitely. So it never ends. But here it's a line segment because it has 2 definite endpoints. So when we have two definite endpoints of a line, we would read it like this. It's called line segment AB. So AB with just a line on top of it. Notice here we put the 2 arrows on either end. For a line segment, we wouldn't. All right, so this would be called line segment AB. This is called a ray. So notice here we have an endpoint on one end, but then it continues on the other end. So we can select a point on a line. This is the midpoint of the line, which divides a line into 2 half lines. And then a ray is either of these half lines, including that point we selected. And then when we write a ray, this is ray AB, and we would show it like this. All right, so it's showing an endpoint on one end and then an arrow on the other end. That means it's going infinitely towards the right. Okay, next we're looking at parallel lines. Parallel lines are 2 lines that are equidistant apart at all times. So meaning this distance between the 2 lines, it will always remain the same distance. And the way we represent parallel lines, here this is line 1 shown as L1, this is line 2 shown as L2. It's a little bit blurry there, but when we represent this, we would write it as L1 is parallel to L2. All right, so this symbol here represents parallel. And again, you've probably seen these arrows here. That also represents that those 2 lines are parallel, meaning they're equidistant from each other. All right, and then a word congruent. You may have heard this word before. This word congruent, it's used in mathematics to describe that 2 figures are equal in all respects, meaning the size, the angles, everything is the same. And this is the symbol used. So it looks like an equal sign with a squiggle on top. That symbol here represents congruence in mathematics. So in this case, we have 2 line segments here. We have X, Y, and we have MN. We can see that both of them are 3 decimeters in length. So we can say that XY is congruent to MN. They have the same length. Okay, we'll pause here. A quick mathematics video on points, lines, and planes. All right, so we get into angles and measurement next. So an angle is defined as two rays. So here is one ray, and here is the second ray. So two rays that converge at one point. So this point here is called the vertex. That's what an angle is defined as, or it's the amount of turn about a point, which is the vertex. So when we name an angle, we use the symbol. It looks like that. That's an angle. And then it's followed by three capital letters. The middle letter is always the vertex. So in this case, we would call it angle ABC, like this. In some resources, you might just see it written as angle B, like this. All right, but if you ever see it written with the three letters, with the three capital letters, that middle letter always represents the vertex. All right, so in this case, this would be angle A, B, C. So angles are expressed by using the units degrees. We see this little circle as a subscript. So there are 360 degrees in one complete rotation, revolution, or circle. If I was to draw a circle here, starting point, and I come all the way around back to here, that makes one full revolution, so 360 degrees. A protractor is what we use to measure and draw angles. Here are three different angles below. This is showing 35 degrees. Again, there's our degree symbol. This would be 65 degrees. And then this is showing 145 degrees. All right, so we're looking at using a protractor next. So the first thing you would do is there's a little hole here called the pen hole. So the protractor's arrow and pen hole is placed on the angle's vertex. And then this here is the 0 degree line. And that's placed over one side of the angle. And then we would read the measure where the other leg of the angle intersects the protractor. So right here. All right, so if this is angle PQR, so PQR, again, Q is our middle letter here. And looking at our angles, we're using the bottom measurements, and it's going up by tens, so 10, 20, 30, 40, 50, 60, 70. So it measures 70 degrees. You can also see 110 degrees up top. That would be the measurement on this side. If we were looking at this side, then it would be 110. So let's take a look at that again here. So the protractor's arrow and pen hole is placed on the angle's vertex. The 0 degree line, here's a 0 degree line, is placed over one side of the angle. So if the 0 degree line is used on the left of the pen hole, then we're going to use the outer edge for measurement. So if we're measuring here, angle ABC, so that would be 70 degrees. We're using the outer edge. If the 0 degree line is used on the right-hand side, on this side, then we're going to use the inside edge. Okay, so keep that in mind. Also, you know 90 degrees is here, and you know if it's less than 90 degrees, then you can make sense of which edge to use. All right, so in this case, both angle ABC, so here is angle ABC, it measures 70 degrees, and when we look at angle PQR, it also measures 70 degrees. All right, so it depends on whether you're using left or right, and then if you're using outer or inner, it depends on if you're using left or right. All right, so our first example, we're looking at angle LMN. So angle LMN, we are using the left side, so we're going to use our outer edge, so 60 degrees, which makes sense. It's not going to be 120 degrees because it is an acute angle. Here we have angle DEF, so DEF. it's either going to be 60 degrees or 120 degrees. What do you guys think that one is? All right, so angle DEF here is 120 degrees. All right, next two examples we just finished. Angle ABC is 170 degrees. Again, we use the outer edge. Here, angle XYZ, it is 40 degrees. Again, we're using the outer edge. Okay, because again, we lined it up on the left-hand side, so we would use the outer edge. All right, two more. All right, so these next two examples, so angle GHI, we're using the right side, so therefore we use our inner edge, so this degrees, the angle measurement is 55 degrees. This one here, angle UVW, we're using the left-hand side, so therefore we're using our outer edge. This is 105 degrees. And like I said, it makes sense because it is greater than 90-degree angle, so it has to be over 90 degrees. All right, that was just a quick answer key. And we'll pause here. Okay, so today's class, we are going to continue with angles, starting off special names that are given to some of these angles. We'll look at those. Last class, we were looking at protractors and how to measure angles with a protractor. All right, so a right angle is what we're looking at first here. A right angle will always be 90 degrees. A right angle here, always represented by a little square there, which represents that it's a 90-degree angle. A straight angle is a straight line, so therefore 180 degrees, if you think about it, if we had a line going through here, the 90-degree angle and 90-degree angle together, it would make 180 degrees. And then acute angle is any angle that is less than 90 degrees. And then obtuse angle is any angle that's greater than 90 degrees, but less than 180 degrees. So let's keep going. Next, we have a reflex angle. This is any angle that is greater than 180 degrees, but less than 360 degrees. So just keep in mind that when we have, I make this like this, so 90 degrees, right? And if we keep going, 90 plus another 90 here, that would make 180. You keep going, 180 plus another 90 degrees makes 270 degrees. And then when we go back to full circle, that makes 360 degrees. So a reflex angle is any angle that's greater than 180 degrees, but it's less than 360 degrees. Okay, number 6 is showing adjacent angles. These are any two angles. They have a common vertex and a common ray. So X and Y here would be called adjacent angles. Two angles that add up to 90 degrees are called complementary angles. So here 40 degrees plus 50 degrees gives us 90 degrees. So those two would be complementary angles. Supplementary angles are any two angles that add up to 180 degrees. So in this case, 60 plus 120 degrees are two supplementary angles. Next, linear pair of angles. These are two adjacent angles. They have to be adjacent and they're going to add up to 180 degrees. So if you have a question where you're given one of these angles and you have to figure out the second one, you can do that by subtracting from 180. Opposite angles. These are congruent angles formed when two lines intersect. So these two lines are intersecting. So this angle here is this congruent to this angle here. So these two are opposite angles. And these two angles, shown here as the black dot, those two angles are opposite angles, and those two would be congruent angles. So here, two lines intersect when they cross each other at one point. So they're crossing each other here at point P. The angles opposite each other are called opposite angles, and they are congruent. So AB and CD are intersecting at point P. So angle APD, this angle here, APD, is congruent to angle CPD, CPB. So those two angles will be congruent. And this is the symbol that we use for congruent. It's an equal sign with a little squiggle on top. Therefore, if these two angles are congruent, these two angles will also be congruent. So angle APC is equal to DPB, or congruent. A perpendicular line here. We covered parallel line last class. Here we're looking at a perpendicular line. So two rays, lines, or segments are perpendicular when they meet and or intersect, and they're forming a right angle, so 90-degree angle. So therefore, we would say that AC is perpendicular to BD, and we use that symbol here to represent perpendicular. It just looks like that, like an upside down T. Okay, so next we get into transversals, and so here we have two lines shown here, and we have this line that is intersecting both of those lines. This line here is called a transversal. So that's the line that intersects two or more lines. Now, when we intersect two lines like this, we have certain angles forming. So here we have something called interior alternate angles. Interior meaning they're on the inside. So these four angles shown here, they're called interior angles. More specifically, these two would be interior alternate angles, and these two would be interior alternate angles. So these are angles that are formed when a transversal intersects two lines. If the lines are parallel, then these alternate angles are congruent. So this angle would be the same as this angle. This angle here would be equal to this angle. They are congruent. And then we have the exterior alternate angles. They're on the outside. So again, if you just look at both, so these ones were on the inside, so interior, and these are on the outside, so exterior. So exterior alternate angles. So angles formed when a transversal, this line is the transversal, it intersects two lines. If these two lines are parallel, then the alternate angles are congruent. So this one alternates with this one, so these two angles would be congruent, and then angle N here and angle N here would be congruent. And then corresponding angles. So again, we have this line here, that's the transversal. So angles formed when a transversal intersects two lines. Again, if the two lines are parallel, then the corresponding angles are congruent. So if we look here, we can see if we took this, all of that, and just brought it directly down here, just exactly like that, we can see the angles are the same. This angle here is the same as this one's the same as this one, this angle is the same as this one, and this one's the same as this one. So those are called corresponding angles. All right, so let's practice some of these questions here using everything we just learned. So for the first example, we're going to take 180 degrees, subtract 63 degrees, which gives us 117 degrees. All right, so x here, angle x, is equal to 117 degrees. Let's take a look at our second example. It's making a full circle, and we talked about how a full circle revolution will make 360 degrees. So how can we figure out this part x? If we know this is 70, we know this angle is 169, we have to figure out this third part. How would we figure that out? Okay, so for this one, what I would do is I would take my 360 degrees and I'm going to subtract 169 degrees. and subtract the 70 degrees. No worries. And you should get 360 minus 169 minus 70, 121 degrees. All right, so angle X is equal to 121 degrees. Okay, so this next example is looking at that concept that we talked about opposite angles. So we have two lines that are intersecting at the same point. So we can use what we know about opposite angles to figure out our angles X, Y, and Z. Okay, so we figured out that angle Y is 72 degrees because they are opposite angles. To figure out angle X, we have to look at this line here. It is a straight line, meaning it's a straight angle, which is 180 degrees. So to figure out angle X, we would just take 180 degrees minus 72 degrees, which gives me 108 degrees. All right, so this is 108 degrees. Opposite to it is Z. Z would also be 108 degrees. So 108 and 108. Good. All right, let's try this example here. Find the measurement of the missing angle. So what we know is angle ABD is 60 degrees. Angle ABC is 28 degrees. So this angle, I'll just label it, is 28 degrees. I don't know why my pen is doing that. We have to figure out what CBD is, but we know that this full angle like this is 60 degrees. It's 60 degrees. So therefore, what would angle CBD? What is this angle here? That's what we need to figure out. This one here. Just put a different color. This angle is what we're trying to find. That's CBD. We would get this by taking our 60 degrees, subtract the 28 degrees, which gives 32 degrees. Good. Okay, let's try our next one here. We know that angle GFH, that's a 90-degree angle. So I'll just put a square there. Angle EFG is given to us as 33 degrees. So we'll just add that in there. 33 degrees. So then what would EFH be equal to? So we would just have to add the two angles in this case. 33 plus 90, which is 33 plus the 90, which gives me 123 degrees. Good. Okay, next diagram. So here we have two lines. This little arrow here is showing that the two lines are parallel, and we have a transversal going through here. And then we have all these angles we need to figure out. We're only given one angle at 58 degrees. We need to figure out all the other angles. So angle 1, 2, angle 5, 7, 6, but we'll just figure out all the angles. Then we have to be able to know which ones are alternate interior, which ones are alternate exterior, giving another pair of alternate exterior angles, and so on. Okay, so let's get this done. Okay, so let's start with down here. Since we know this is 58 degrees, angle 6 will also be 58 degrees. So I'm just going to label that here, 58 degrees, and I'll fill it in right here as well. It's 58 degrees. Angle 5, we can figure out angle 5 here because a straight line makes 180 degrees. So 180 minus 58 will give us angle 5. So 180 minus 58 gives me 122 degrees. So angle 5 is 122 degrees. All right, and because we know angle 5, opposite to it is angle 7, that will also be 122 degrees. All right, so angle 5 was 122, angle 7 is 122. Now we are going to use our concept of corresponding angles. All of these angles are corresponding here. So they will all have the same measurement as well. So this angle 5 would be corresponding or congruent here. So that would be 122 degrees. 2 and this angle, that would be 58 degrees. And then we know angle 3 would be 58 degrees. And then angle 4 would be 122 degrees. All right, so angle 1 is 122, and angle 2 is 58. Angle 4 and angle blank are alternate interior angles. So let's go to angle 4 is here. Therefore, its alternate interior angle would be here. So angle 5. All right, those are alternate, two examples there of two alternate interior angles. Angle 2 is an exterior. Its alternate exterior angle would be this one here on the outside, so therefore angle 6. So angle 2 and angle 6 are alternate exterior angles. Another pair of alternate exterior angles would be angle 1, which is on the exterior, and angle 7. So 1 and 7. 3 angles that equal 58 degrees. 3 angles that equal to 58 degrees. Angle 2, angle 3, and angle 6. So angle 2, angle 3, and angle 6. Next question. Angle 2 and another angle are a linear pair of angles. So here is angle 2. So we can use angle 1 for that linear pair to make that straight line, but you could also use 4. So it could be 1 or 4 for a linear pair of angles. All right, 2 pairs of opposite angles. Any 2 that are opposite angles, so 1 and 4 here are opposite angles. 2 and 3 would be opposite angles. Like 5 and 7 would also be another pair, but we just have to give 2 examples. 2 pairs of corresponding angles. So corresponding angles, so angle 1 and angle 5 would be an example. We can also use angle 3 here, and angle 6 would be corresponding angles. All right, so just make sure you are familiar with those new terms that we've just gone over. So alternate interior, alternate exterior, corresponding, opposite, and so on.